So I'm going to discuss about a very much more pragmatic form of complexity, the one that you have to manage when you want to build software solution for building and making a cities becoming more smart than it used to be. So the outcome of my presentation will be first, I'm going to show you 3 use cases of managing the complexity of city where I've been involved in. I've developed the software. I've been very much an actor in developing those software solutions. So I'm going to first refer those 3 use cases to manage complexity of cities. Then I will, discuss very rapidly this notion of algocracy, which basically means we are being ruled by algorithms. We more and more entrust our living together to algorithms. And so what does that mean? How do we legitimate the control of algorithms on our daily lives? More and more algorithms are really ruling our lives. So I would distinguish 2 different notions, 2 different type of algorithms. The one that do recommend, do advise, like GPS, like Tinder, like whatever. And the one more and more invading our life, which constrain, oblige, and like, for instance, the algorithms to register to university in France, or some algorithms to get credit in bank. So those algorithms are much more, to some extent severe, because they do rule our life in a much more obliged way. Then I would discuss the legitimacy of the use of those algorithms, the one that do constrain more our lives. And I'll show that one way of legitimating those algorithms is to make the citizens, the ones that are being, subject or victim, if you prefer, to those algorithms, to take an important role in the programming of those algorithms. So this, to some extent, pushed to a kind of new form of democracy, which is much more participatory. Our computer scientists, we're very much used to share, to work together on some platform like GitHub or whatever. But I like to generalize this idea to common people, naive people, the ones that are being really object and subject to those algorithms, to take a more important part in the writing of the code. So this is some experiment that we're trying to develop in Brussels in a new institute that I've created 6-7 years ago called FARI. And the FARI, if you can just Google the website, and you'll see that it is a pretty ambitious institute that I'm going to a bit describe in this talk, where the main topic is really to describe and to develop algorithms for the common good. This is really important notion, the common good, and the common good at a scale of a city like Brussels. Brussels is an experimental city for that, but I do imagine that the kind of problem that I'm going to describe to you also apply to Casablanca, Rabat, whatever, any kind of city, some similar kind of problems. And so I'd like to see some very similar, institute being created in other places in the world. So 3 use cases that I have developed myself. I've coded those solutions. So the first one is mobility. As you know, mobility is one of the most critical issues when you try to rule a city. And we've developed with some of my colleagues in this institute, we've developed a solution for multimodality. So this is an application that we've developed in FARI, and where there is solution for mixing modality, because one of the complexity in mobility in city is the emergence of a lot of new ways of like bicycle, trottinette, car sharing, public transportation, your own car, the car you share. So there are a lot of possibilities. Like I think in Belgium, for going to point A to point B, today you have something like 30 possibilities, And an important issue is how to mix those modalities. So for instance, you take a bicycle to go to the stop of a public transport, then you take a bus, then you can share a car, so you have different mix. And this is definitely a very complex problem. And anytime I will show you some kind of complex problem, I will show you the kind of AI or software solution that we developed in order to deal with those problems. Another interesting complex problem is car sharing. How do you share a car when you go to point A to point B, and you like to pick during the transportation some people waiting for. And there are a lot of complex problems, and in fact, who is trying to tackle those issues are the GAFAM, like Google, Google Map, Waze. And this is what I'm trying to criticize, and I'm trying to deal with is to try to develop our own solution for those things, not relying so much on the Google and whatever kind of solutions. So and I think it's important to redevelop those solutions locally, excuse me for the French, but developing an interesting mobile solution in cities needs to take into account a lot of reality in the cities that Google Waze can't take into account, like the time for parking, the duration for parking, the work that are being done in cities, a lot of things that we people, the politics in the cities knows, but the GAFAM have difficult access to. And you see that this is a real complex things. And the kind of algorithm that we use for that is pure A*. So for those people, not everything in AI reduced to ChatGPT or deep learning. There's a lot of interesting solution in AI developed back in the 80s for facing this kind of complexity. A* is a bit like Dextra, but it's a much more sophisticated form of Dextra. It's a very interesting algorithm finding those issues. And when you do multimodality, you have to apply A*, but on different graph. And every modality has its own graph. So for instance, bike has its own graph, public transportation has its own graph, car has its own graph, and you have to find solutions that go through the different graphs. It's a very interesting computational problem, highly complex. And as you know, it's NP things, so the more possibility you have, the longer time it takes to find a solution. So this is some problem that I try to deal with and tackle in my new institute. And there is a lot of interesting paradox, by the way. If you're interested in prisoner dilemma and those kind of things, game theory, there is an interesting paradox in mobility where if everyone tries to maximize his own interest, the whole issues become catastrophic, like in the prisoner dilemma or in a lot of game theory. So mobility is full of interesting issue of complexity. So I really recommend people interested in complexity to deal with those very pragmatic issues. So another one, and this to some extent raised the birth of my institute, was COVID. During COVID, as you may have seen, there's been an invasion of a lot of algorithms, a lot of software solutions for tracing the infected people, for getting to restaurant, getting to public place. And I remember that during COVID, there was a very complex problem that appeared in Brussels, was during the vaccination campaign, because you needed to know how many, for instance, doses of vaccines you had to distribute to the different centers. How many centers did you need? How many vaccinators did you need in the centers? Also, it was really important to see if everyone wanted to be vaccinated. So there was some district in Brussels where there were much less adhesion to the vaccination than other districts in Brussels. So you had to distribute. Also, you had to think about 2 doses of vaccine. Some vaccine was 1 dose, some other vaccine was 2 doses. It was a very complex problem. And I built a full software with my colleagues for ruling and organizing and managing the vaccination campaign in Brussels. You see that this software was exposed to some important people like Ursula von der Leyen, because Ursula von der Leyen, as you know, the president of Brussels, president of Europe, excuse me, she had to be vaccinated in Brussels. So we had a lot of discussion of how this vaccination software work. And that is one of the reasons why she financed the AI Institute for Public Goods, because as you may remember, when she took the direction of Europe, and she's still president of Europe, she said that Europe had 2 important missions, AI and the green transition, the Plan Vert. And AI was really on the horizon, so she was very interested to see what we were doing with the vaccination campaign. Here you can see the King of Belgium, also that has to be vaccinated in Brussels, and wanted to see how the cockpit was ruling. We had to do a lot of interesting algorithm. One of the algorithms that we used to match the people to the dose of vaccine is an algorithm called Gale-Shapley, and it's a very classical algorithm called the stable marriage algorithm, the one which is in fact in use in Parcoursup. When you try to match different kind of agents, you use this kind of algorithms. And here the matching was between the people that wanted to be vaccinated and the dose of vaccine that there was existing, etc. You had to match. Also, you had some priority. The older people needed to be vaccinated first. The one doing very highly priority work needed to be vaccinated first. So you had a priority to access to vaccination. You had also priority of the centers, the vicinity of the centers, the neighboring of the center. So it was a very interesting matching algorithms. We needed needed to use a lot of machine learning. We needed to predict the number of people being vaccinated in some place and some others. The poor people were less accepting vaccination than the rich people. That was, you know, the reality we checked, and we had to deal with that in order to build the vaccination cockpit. And it's interesting that to see that in France, although they create a lot of web solution for, you know, organizing this vaccination campaign, and Macron spent millions of euros to McKinsey in order to organize this vaccination campaign. The one who finally built the website that was the most visited for the vaccination was a young student in his room. He got even the Légion d'honneur after his work. This explains why, you know, you don't have always to rely to big company, big consultancy company, even the GAFAM. I mean, people in a university, young people can often, and this is what I'm trying to attract in my institute, young people often build much better solutions than what people in consultancy company like McKinsey, and much cheaper, because I can tell you that my cockpit of vaccination was nearly free, while McKinsey asked millions to Macron in order to organize the vaccination. So the last example, which I heard a lot in other rooms yesterday, was this energy community, which is a spreading model for energy reduction, energy consumption, which is being very popular in a lot of countries. And I would say that in Morocco with the sun certainly is a very popular type of technology. I heard a lot about blockchain. Managing energy community is an interesting AI type of problem, because, for instance, you have to decide about the way you're going to distribute the energy. So it's even a very philosophical, interesting problem, because you can be utilitarian, you can be equalitarian, you can be Kantian, you can be, it's interesting to see that you can share the energy in very different ways, and you have to develop solutions for that. And in order to develop a solution, you need to do a lot of AI. So, for instance, predicting the electrical consumption. Because, for instance, if you decided to distribute the energy as a function of how much energy you'll need in the future, you need to be able to make a lot of prediction about what will be the consumption or what will be your solar panel production. So there is a lot of machine learning and prediction that you need to, you know, implement in those systems. Other interesting software solution is what is being called disaggregation, which is a very interesting challenge today in energy. You need to be able to understand which device, which apparatus is consuming what. So, because, for instance, when your car is being loaded or when your dishwasher is working, it's important to be able to pinpoint those things in order to rule and organize the distribution of energy among the members of a community. So, this is different use cases. What is interesting in those three use cases is that you have to do a lot of AI, a lot of data science, a lot of optimization. Every tools of AI, every tool of the toolbox of AI can be, you know, used and exploited in those kind of problems. But the other thing is that you need to have a participation of people, the participation of a member. In both cases, that was the case for vaccination. You need to have the people understanding what is going on. Certainly for energy sharing, you need to have the members of a community agree on the way the energy will be distributed. So for all those three use cases, you need to inform and have the acceptance of the members of this solution to play a role with this development of algorithms. So this notion of algocracy, which is my second topic, is the idea that our society, us, our human being, we're being more and more ruled, controlled, constrained by algorithms. So there is two generations of algorithms. There are the first generation, which is not as much constraintful, even if we more and more rely on those algorithms to decide our life. For instance, the recommendation algorithms, algorithms like Tinder for meeting your new lover, or algorithms for, you know, GPS. You can decide to not use them. You can decide to stop them, but you use them often a lot because they're very helpful in most cases. And you have this second generation, which are algorithms that oblige, algorithms that are unavoidable, that you can't bypass. You need to go on those algorithms in order to acquire a ticket for an airplane, or for register to university, or to get into a public transport, to get a credit. And what I'm thinking is that more and more those algorithms will take the lead in our life. So we're gonna, you know, gradually shift from the first generation of algorithms, which have already the possibility to constrain, to the second one, which have no other possibility that constrain you. And I think that this will take more and more place, and we see that because it's a way of facilitating and reduce the complexity that Jean-Paul was mentioning. You know, you simplify the social reality by, you know, making everyone following an algorithms that is much more constrained. It's a way of simplifying a complex society. And COVID has been a fantastic example. You know, you could imagine a lot of the possibility for ruling our life during COVID, but you've seen this invasion of algorithm and software everywhere, in every place. You had to download on your smartphone. I don't know what was the case in Rabat or in Morocco, but in Brussels, in order to face the COVID crisis, you had to download something like 4 or 5 applications to get to restaurant, to trace yourself, to register to vaccination, to get the test, the PCR test. You remember? There was a lot of application on your smartphone, otherwise you wouldn't be able to face this. So COVID was a fantastic example for me, an experiment taille grandeur to see the importance of algorithms taking in our lives. You have obviously the classical example of China, where, you know, you have this social credit, where in theory, it's not exactly like that in China, but there's a lot of phantasm about what is happening in China. But we often heard about this credit, social credit, that every aspect of our life is being, to some extent, registered, evaluate, and according to what you do, you'll have some reward or punishment that will be very concrete, and this is a purely algorithmic control of life. There's an interesting YouTube movie that you can, if you are interested in that, called My Wife Got Some Credits, and this is a French journalist who explore and discuss this invasion of algorithms in our daily life in China. So, well, you can obviously criticize that, and the more those algorithms become constraintful, the more there is no way to escape that, the more philosopher, jurists, politicians are obviously criticizing this. Like in France, there is a lot of discussion about Parcoursup. Do we have to maintain it? Do we need to get rid of it? You know, this is, in Belgium, we have exactly the same. In order to register to school, not the university, but the more elementary schools, you have to go through an algorithm that would decide which school you can register your kid to. So you see, your life is very constrained by algorithms. So jurists, philosophers, were very afraid about that. And I can follow them, you know, I can go on track with them. So there is this interesting notion that if algorithms taking our life, controlling our life, there is a philosopher who call it code is law. There is no more law, there is code. So just to give you an example, you can't take your car when you're drunk, okay, this is law. And you see that you have more and more devices that will prevent the car to start up when you're drunk. So for instance, you can imagine a device in your car that when your breath has certain alcohol inside, the car will not, the engine will not start, you know. And you see that the law, which is forbidden to drive when you're drunk, will gradually be transformed in a device. And this evolution is taking place everywhere. You know, algorithms, software is ruling our life. In theory, trying to respect the law, but you realize that when you make this mutation, the algorithm is much more efficient than the law, because the law you can discuss, there is an advocate, you can a procurator, you can law, but a code, you can't violate a code. A code is much more constraintful, an algorithm is much more constrained, so it changed completely the philosophy of law, and this is a society that we are more and more living in, and the GAFAM is pushing the lead for that. And we are living in a society which is much more and more Truman Show-like, you know, where, as you know, it's kind of an artificial society, formatting society, where our life has been taken in charge by big computers, which are deciding for us what we need to do next. And the GAFAM, as I said, and if you think about the power that have taken the GAFAM this last 20 years, and I'm not even speaking about ChatGPT, I'm speaking about smart meters in our home, I'm speaking about mobility, I'm speaking about healthcare, I'm speaking about even COVID. If you remember COVID, the tracing algorithm that you had to put in your smartphone was a development of Apple and Google, you know. So you see that they are everywhere trying to rule our life in every... This was one of the reasons why people rejected the tracing algorithms, at least in France and in Belgium, was because Google and Apple was, you know, taking our data and do things with that. So what is an answer to that? It's my proposal. This is what we try to, I'm still 5 minutes, 10 minutes, is it okay? This is my proposal. This is what I'm trying to do in Brussels. I believe that those algorithms that are becoming so severe, so important in our daily life, need to be developed in another way. So I'm defending and advocating 3 groups of developers. So definitely you need experts in algorithms, things like computer scientists. So no big deal with that. You need those kind of experts. But this is really important. You need another kind of democracy where citizens should take place in the development of algorithms. So this is a very difficult thing to do because you have to take them randomly, for instance. There's a lot of experiments of participatory democracy who's trying to do that. You need to educate them in order to understand a little bit about the algorithms, like what is A star, what is a recommendation engine, what is a machine learning doing. You have to make a little bit of literacy, but this is becoming more and more easier. And then you need also some kind of election, because otherwise you won't be able to resolve everything, because there would be some disagreement. And I guess that some form of election, but not everything restricted to election, because as we've seen, election is often a nightmare, a dread thing, because I mean, you need different form of participatory democracy for developing new code. So I'm trying to experiment that for the 3 use cases that you've seen initially in my talk. We're trying to do that in Brussels for mobility, for car sharing. During vaccination, I wanted to implement that, for instance, to see if everyone were agreeing that some district, for the priority was really important. Who should be vaccinated first? It was surprising that depending on some countries, the priority of the ranking was different. You know, for instance, in France, it was not so obvious that the older people should be vaccinated first than the young people. There was a lot of discussion about it. Like in Asia or in Japan, it was obvious that the old people should be vaccinated first. It's a local algorithm, so you can adapt the criteria depending on the culture, depending on the, you know, the philosophy. An algorithm is very adaptable, it's very flexible. You don't need to be, a law is much less adaptable and much less flexible than an algorithm. An algorithm, you can just change the line of code and you will make it run in a completely different ways. So this is, and this is this notion of an extension of GitHub, but to a social coding, you know, citizen coding. So not only expert programming, etc., but the layman, we have a lot of platform making easier this kind of sharing, so we can expose the algorithms to anyone who would like to participate and explain the algorithm to him or to them, to her, and try to make them participate. And I think the best way for people to accepting to be ruled by algorithms is that they understand that the algorithm becomes transparent. And the best way for the algorithm to become transparent is that if they took a role, they took a part in the development of a code. So this is, as I said, what we try to do to the access to school. So in Brussels, we have an algorithm which is a Gale-Shapley algorithms. And I explained the Gale-Shapley to the people in Brussels, and I tried to see if they were agreeing with the ranking, because Gale-Shapley imposed some kind of ranking from one side to the other side. Do they agree with this kind of ranking? And if they agree with this kind of ranking, they would accept that the algorithm decide for them, even if their kid is not in their favorite school. To the moment they understand how the algorithm works, they would accept that, you know, it's objective, they've decided about it, and okay, they might be victim of it, but at least they accept this victimization. We did it for vaccination. We tried to do it for vaccination, we didn't succeed. I'm trying to do it with mobility. In fact, in Brussels, just an anecdote, there was a strong ecological party in Brussels who tried to modify completely the mobility in Brussels. They proposed a plan called Good Move. The plan was a disaster. They didn't, you know, make people intervening in the plan. They tried to do it software, but they did it badly. So it was a pure chaos, pure disaster. And the ecological party made, at the last election, they made 1%. So they completely collapsed due to completely failure in the development of an algorithm for mobility in Brussels. So you see the importance of mobility is taking in cities. So you can completely ruin our political career if you develop the bad algorithms. So FARI, I recommend you to go and look at FARI. FARI was an initiative financed by Ursula von der Leyen. So herself, she decided to give us a check of 20 million euros to create this institute. That is an institute that if you visit Brussels, you can go and visit it. It's a very big thing, and it's a very interdisciplinarity institute with philosophers, It's a 400 researchers institute, so it's a pretty big institute with philosophers, economists, sociologists, computer scientists, engineers, so different type of people. And I think it works. We're trying to do a lot of experience with citizens in Brussels, develop a lot of solutions. It's not an easy job because the public administration in the city, they are very hard to convince. They're very conservative, very inertial, but at least we're trying to achieve that. And we really want to reconquest the development of algorithms at the level of the city, developing our own algorithms for managing Brussels. This is the dream. This is what we aim at. It's not an easy job because the reflex for public administration is the GAFAM or the consultancy administration like McKinsey, Deloitte, and others. We want to break with that. I believe that in university, there are much more bright young researchers that can develop much brighter and much more interesting solutions for a lot of problems in the city, and much cheaper. Much cheaper than what will be asked by a consultancy company. So conclusion, and a different slide to that, but this is the last picture I wanted to show. You may recognize this woman who is a woman that I like a lot, called Elinor Ostrom. She got a Nobel Prize, I think in 213, for her work on the common. And there is a new notion that is being very popular in my vision of the world, but many people share this vision more and more, which is this notion of numerical commons. So keeping that same idea, it's a self-organized form of democracy that existed in the common back in England in the 17th century, that has been erased by the new form of politics, but common was really popular. People self-organized in order to develop their own rule of governance, so it was a very kind of ideological, but it works until the 17th century. But now there's these similar things for algorithms, for developing algorithms. So numerical common is this idea that you make people together, not only developers, but also the people that will be affected by these developments to take place and to take a part in the development of things. And some also, politicians might take place a role. And right, I think I'll finish with that. Elinor Ostrom, at the end of her life, discovered GitHub, discovered this open source type of thing, and she was really fascinated by that. She didn't have time to write about it, but there is a little paper where she said, this is the future, or this is the resurrection of a common like I knew them back in the 17th century in England, to see that in the software developers community, the one that developed open source code, is exactly the philosophy had that I've seen in the 70s in England. So she was very happy to see this revival, and I want to push it to the governance of cities like Brussels and perhaps other cities in the world. Thanks for attending. Yeah.
Oh, yes.
Hello. Thank you so very much. Inspiring talk. My name is Louis Klein, Dean of the European School of Governance. What I'm wondering, or what question comes out for me out of your talk, is a notion of an ecology of code. How does the different gadgets, how does the different approaches to code sit together in an ecology of code? Where do they compete? Where do we find mutualism and symbiosis? What is your take on that?
Well, it's a very interesting question. Well, you could do first kind of sociological study of what is happening in some platform, for instance, the development of, Linux, or the development of Wikipedia even, it's interesting to see that the rules for Wikipedia has really emerged out of the experience of Wikipedia, and there's been a lot of competition for some, articles of Wikipedia. How this competition was resolved, there's been some people have decided to elect as much expert than others, but that was a kind of self-organizing process. So I think it depends on the code, it depends on the kind of thing you want to do, but it's really experimental, empirical. You have to try things. And I'm here with Wikipedia and Linux, I'm only speaking about coders. To the moment where you involve people who don't know a lot about coding, or if you involve politicians in that and you put them all together, this is exactly the kind of experience that I try to promote in Brussels. We started with. And the best example is the energy communities. So this is an example that we've concretized to the point where we have finalized an algorithm where people have selected to split their energy in some way. It took some time because we had to explain them, the machine learning process, how we could, predict what they're going to consume. They had to agree on also a pricing, because there was a pricing. So it took time. We use a lot of psychologists inside that, because only us wouldn't have been able to do that. But we succeeded. At the end, we had an algorithm that respects the wish of the people. So I don't have a rule. I'd like to have enough experience to write some book about it, but it's very embryonic, very preliminary. So I couldn't tell you exactly the way you had to do that. But it's an ongoing thing. Thanks for your question.
Yeah, thank you very much, Hugues. That's a fantastic accomplishment and the very nice visions. I shared a lot. So I have two very quick questions. So first question, does FARI offer the potential opportunity for collaboration?
Oh yeah, sure, definitely. We open to that. We have collaboration with Montreal, with Paris, with Bologna, etc.
Great, thank you. Second question is we are probably reaching the age when everybody can code without knowing the computer program. Like a high school student can just build app without knowing Python. So that changes the landscape quite a lot. So what's your take on this?
Well, even with ChatGPT, it's become even easier to code. You just have to prompt and you get the final code. So yeah, you're right. It makes life easier because, I think that the discussion will be really at the level of algorithms. You don't need to get to the level of coding. So for instance, if you think about the Gale-Shapley, the only thing where people had to agree in the ranking, who is priority, etc. Because you explain that, the first go to the first, so the second goes to the second, and then you have to explain that a little bit. But it's easier to explain. Even an A-star, the A-star algorithms, and you can explain that without having to code it. When you code it, it's becoming much harder because you have to understand the notion of pi, if you've coded an A-star. But I guess you can explain in a very general way, how this algorithm is working without dealing into the code. And you're right, today with this prompt engineering and way of coding, which doesn't require to be able to master programming language, things should become ideally easier. You're right.
Yeah, thank you for this very good presentation. I have two questions. First, to build on the ChatGPT discussion, of course, we have now to learn to talk to machines with natural language, but still the machines has their own, because it's generative. It takes the data that you give him, but he has also his biases. And there is also this explainability of the algorithms that is written by the ChatGPT equivalent that still has to be verified to make sure that what has been decided is what is implemented. And still we are not in agentic era yet. So they still create the code, but they don't run it actually. My second comment maybe is about, now we are talking about politics. And in politics there is lots of thoughts, wings, right one, left one, and lots of, let's say, courant politique. We obviously didn't find a way to solve it by democracy, because it's still everything is about still you have these waves of politics that change every 5 years, etc. So how an algorithm can deal with this contradiction? Because for instance, if you see the US, there is 50% of people that are on one side and 50 are the other side. So how an algorithm can maybe find a more a better way to align people, even with transparency?
It's a very hard question. The first one, I don't want to comment on them because it's really a discussion about those, generative AI for coding, and there's a lot to say about the quality of that, but it would be a completely different talks, and I'd be happy to discuss that with you. I have my own vision of it, but it's a very long talk. On the second one, it's an important aspect. I guess that, if we accept that our algorithms are going to rule more and more our life, and if we have to entrust algorithms for doing so, I think we have to modify a lot the way these algorithms are being implemented and accepted. So I got the feeling that with the, there is this notion that, you know, in politics we have three different regimes: the executive, the legislative, and the judiciary one. What is really changing is the executive power, you know, because we give more and more of the hands to algorithms. And if the executive power is changing and it's taking more and more by algorithms, then I believe that the legislative power should be modified too. Then we have to legitimate those algorithms in a different way. It's not possible to let everything in the hand of a GAFAM. You know, even if you think about Parcoursup in France, the way it has been developed, it's not really democratic, you know, because the real concerned people like the students or the academic, they were not really implemented in that. So we have to modify also the way we're gonna, so I mean, it's modify the political regime. It's not a question of election. And I think this is feasible. We have to start, this is the reason why we started Brussels. We have to start local scale. I'm not trying to modify the, the bipolarization in the United States with this kind of idea, but I believe that, you know, things that people are really concerned of, like mobility, access to school, vaccination, and this is things that you can, this is reality that are important at the local level, and at the local level you can have people sitting together and discussing about it. And I think that because at the end you'll have an algorithm that will be really written in the marble of things. You know, the algorithm will do exactly what people wanted it to do. This changed a lot, you know, the way people will accept to discuss, because they'll know that at the end they'll get an algorithm that respects their wish, you know. So, and with energy, the community of energy, which is the experience we've driven as much as possible, it works extremely well. People were very happy to discuss about the way they would split their energy among themselves. So it was a very positive experience. And I think it would have been the same for software like Parcoursup. They didn't do it, but I think they have to change their mentality.
Last short question, please.
Yeah, Masaf Nabashi from Sony Group. Thanks for the great presentation. I'm
Thanks.
also passionate about this open source initiative. And my question is concerning the interface with the natural world, because, okay, we have to do some collective organization with Algocracy. I'm totally on it, at least to clean up individual stupidity from human side. But at the same time, there's so-called framing problems in artificial intelligence. We cannot measure everything like in the natural world. There's huge complexity that, in line with the previous presentator, for example, we cannot comprehend or compress totally, which would actually deviate the collective optimization in a catastrophic way. Recent example in the carbon market, for example, there's lots of checklists, well-defined process, so it should be optimized with the support of this algorithm, for example. But it turned out to be very negative because inside it's going well, but actually the company is making the road, cutting down trees to get access to this site, for example, so it's totally it's carbon positive, things like that. So how we can have the remedy to overcome this collective stupidity, even if we could go beyond the individual stupidity?
Thanks for your remark. It's a fascinating remark. You know, once you have an algorithm, there are many ways to free ride and to bypass and to cheat with it. And I'm pretty sure that this will happen. You know, and because it's an algorithm, there will be clever people that will be able to, you know, trick the things and do their own stuff. And as you know, for the carbon trading and. Yeah, that might be true, but I need to be optimistic. You know, I guess that if you, this is the reason why, you know, the reality is much simpler when you play at a local level. You know, the carbon trading is a thing that is, you know, try to modify totally. When you do in a local community energy sharing, which is a form of carbon trading too, you know, because you negotiate the way you're going to split and basically you try to reduce obviously your energy consumption, because that is also the aim of those things, because there are solar panels, etc. I think you can help people, but first the reality is simpler because it's more local, so you have less actors, so you can deal with that. And I guess that if you make people really working together, you avoid the problem of game theory or prisoner dilemma or whatever, because they really cooperate, they know each other, and they don't want to cheat the things, you know, because, you know, you can easily detect the one that's going to cheat, etc. It's less, I guess you would say it's less easier to trick the whole system once people have been much more involved in that. I'm kind of optimistic about it, you know. We haven't tried enough to see if it will work, but I guess people are so rejecting the classical politics and democracy, well, like it's written today, that we need to try different things, you know. And there's been experience in France, in Italy about participatory democracy, and it seemed that the kind of decision that they collectively took would have been better if they would have been applied at the end than the ones that are being taken by politicians, which are much easy to corrupt, that laymen who are not thinking about elections, that just make one-time experience but are not caring about salary or not caring about elections. So that make me optimistic about these kind of things. But it's hard to implement, very hard to implement.